Welcome back to Study with Sri. Today we learn one of the most powerful integration pattern in calculus. When you see something like f prime over f of x, it usually becomes ln. This rule helps you solve many exam integrals in seconds. So let's start with something you already know from differentiation. You know the differentiation of ln x with respect to x is equals to 1 over x. Now the super important extension is the derivative of ln the modulus of f of x with respect to x is f prime x over f of x. Now if I cross multiply and integrate both the sides, I'll be having ln f of x plus c is equals to integral of f prime x over f of x into dx. And this is the important idea that we're going to discuss in this session. The ln f of x plus c, the integral of f prime x over f of x is equals to ln f of x plus c. And if there is a constant k f prime x over f of x is equals to k times ln mod of f of x plus c. This is basically the chain rule in reverse. So here is the easiest way to think. So whenever you see this kind of a question, here is the easiest way to think. In the exam, look at the denominator. Call the denominator as a f of x. And then differentiate it and find out the f prime x. After you figured out the f prime x, compare this with the numerator. If the numerator is exactly f prime x or else a constant which is multiplying with the f prime x, then the integral is ln of the denominator. So your brain should ask, is the numerator the derivative of the bottom? If yes, it is ln. Now, you might be wondering why we are writing ln f of x with modulus. You must understand, sometimes f of x can be negative, but ln works only for the positive inputs. Sometimes f of x can be negative, but ln works only for the positive inputs. So the mathematicians use ln f of x modulus. This makes whatever the input, the ln becomes positive. The modulus of something, regardless whether it is negative sign or positive sign, the modulus of something, the modulus operator make it always positive. So if you are fine with the basic idea, let's work out some examples and try to understand the beautiful idea of this integration. Let's see an example. Let's try to find out the integration of 2x over x to the power 2 plus 3. So what did we discuss earlier? We know first we have to identify this is f of x and find out the f prime x. What is f prime x? The derivative of denominator is 2x. Now compare the f prime x with the numerator. Is it the same? Yes, it's exactly the same. So we can say, so this is the pattern. So I can write the answer is the integral of 2x over x square plus 3 is ln modulus x square plus 3 plus c. Whatever the x value, the natural logarithm is always positive. The modulus makes it positive. So our final answer, ln modulus of x square plus 3 plus c. Here you can see this x square plus 3 is our denominator. So this integral is basically saying what function has the derivative of 2x over x square plus 3? Answer, ln of the bottom. ln of the bottom, because ln differentiate to f prime over f. f prime over f. Let's see one more example. So let's try to find out the integral of tan 3x. Integral of tan 3x. Students, tan integrals are very common and there are two clean ways. The tan integrals are very common. There are two clean ways. So first way, let's convert the tan into most intuitive way. Let me write the tan 3x as a sin 3x over cos 3x, one of the basic trigonometric identity. Now instead of integrating tan 3x, let me integrate sin 3x over cos 3x. So this is numerator denominator pattern. Now see, the denominator you consider as f of x. Try to find out the f prime s, the derivative of cos 3x. The derivative of cos 3x is minus 3 sin 3x because the derivative of cos 3x is sin 3x. Derivative of 3x, it's minus. Derivative of 3x is 3. Derivative of cos 3x is minus 3 sin 3x. Minus 3 sin 3x. Now let's use the substitution. F of x is cos 3x. F prime x is minus 3 sin 3x. But the problem is, we're gonna compare the f prime x with the numerator. In the numerator, we have sin 3x, but not negative 3 sin 3x. Negative 3 sin 3x. So how can I manipulate this into just negative 3 sin 3x? Negative 3 sin 3x. The simple idea. Let me multiply the numerator by minus 3 and divide it by negative 3. Let me multiply by negative 3 and divide it by negative 3. So this manipulation makes the f prime of denominator is f prime of the denominator. The f prime of the denominator is numerator. So now we can simply write our answer must be minus 1 by 3 ln modulus of cos 3x plus c. So if you have a doubt, if I differentiate cos 3x, I will be getting minus 3 sin 3x, but I have sin 3x only. So to make it minus 3 sin 3x, I multiply by minus 3 and divide it by minus 3. So I'm not changing anything in our primary question. So it's gonna be minus 3 over minus 3 over minus 3. Minus 3 over minus 3. So our final answer, minus 1 over 3 ln cos 3x plus c. So the quick recap. So this kind of idea. So whenever you see these kind of questions, see whether it is fractional form, see the denominator, consider the denominator as a f of x, find out the f prime x, compare with the numerator. If the numerator is identical or else if it is multiplying with the constant, then the integral is ln. The integral is ln. So checklist, denominator is f of x, differentiate it. If numerator matches, it is ln. Pull out the constant if needed. So this is the fastest marks in calculus if you recognize it early. So this is a very interesting thing. So now pause and try these questions. and use the ln test. Figure out whether the numerator is the derivative of the bottom, and try to do this question and put your answer in the comment section. And if you have any doubts, you can let me know so I can explain in the next video. And you can try one more question. Tan of 5x. Try this question, and if you have any doubts, you can write your doubts in the comment section.